This is the Critical Design Review report for the Rattle and Roll Rat Removal Project as part of the ENG4000 course at York University. This is the model example for a video-based CDR. So what is the project that we're working on? Effectively, what we're trying to do is figure out a way to remove rats from a typical university campus, because having rats on campus is not hygienic, and if we want to improve the health and well-being of people on campus, we should get rid of rats like this. And we want to do this in a safe, hygienic, and effective manner. So what are some of the questions that are related to the challenges of our project? These came up during the preliminary design review. One of these was, what are the most effective rat attraction mechanisms? And the research, the scientific research that we've read, has said that we should be focusing on sound as the main modality for getting that done. The bottleneck, the critical point that we came to when trying to prototype something to determine if we could do it, was how would we generate the sound profile that was being described in the scientific literature? Another thing that came up was, how could we and how would we store up to, say, 1,000 rats humanely and hygienically for a typical weekend, so 2 days? And the obvious answer to this was that there are good systems in place in medical and industrial facilities for storing and keeping rats healthy and alive during periods of at least 2 days, often more than that. The other thing that was important to point out was, at this point of the stage of our project, we do not have formal research ethics board approval, and that's something that we are currently working on, but it affected the way that we implemented our prototype and conducted our work. So how are we going about solving this particular problem? Well, we have developed a prototype, and that prototype has a number of constraints. The work itself involves the generation of sound to attract rats, and it is inspired and determined in large part based on our interpretation of an important piece of literature called the Pied Piper of Hamelin. We currently have no rats to test on because of lack of Research Ethics Board approval. However, we have conducted a survey of the scientific literature on the use of sounds to attract rats, and you can see some of the citations at the bottom of the page right here. We know that if we're going to do this properly in the prototype stage, but also later on in the development of a manufactured device, we want to keep the cost of electronics and associated components low. We also know that we're going to have to measure the error between the desired sound from the literature and the one that we generate with the electronics that we have. Those electronics are described in a separate prototype video. So how are we going about solving this? Well, we've taken some information from the literature, and we have a profile for sound that can be used to attract rats. We know that we can implement it with low-cost electronics, in this case an Arduino system with an audio amplifier and a speaker. And using the sound that is generated by that Arduino system, we can then do an evaluation against the theoretical sounds that were described in the literature. So we want to do a comparison between these two sorts of signals to determine if we're on track. So what was the outcome of the test that we did on the prototype? We found that our system was generating sound within 10% of our target range. We did find that there were some limitations, including the fact, obviously, that we didn't actually directly or indirectly test the system on rats. Our system is currently not robust, nor is it mobile, something that needs to be worked on down the road. We have not tested with any significant ambient noise, and that is something that needs to happen down the road as well. The range for our system is currently unknown, and the effect of acoustic reflections in environments where rats would normally be present, there would be lots of objects, and how those objects would interfere or modify the sound that is being used by our sound generation system is currently unknown. So how has this work informed our design? Well, the first one is that we've realized that the sound quality isn't as good as we'd hoped. And we believe that that is an artifact of the 8-bit integer-based math that is currently available on the Arduino in the Arduino's hardware. We believe that switching up to a fully 32-bit system with hardware-based floating point will help us create a better, more realistic, better matching sound profile. We have, in the process of conducting this work, narrowed our requirements from general attraction devices to specific sound generation systems. We know that we can interface, and we'll have to create a more simplified and handheld version of the interface, and that we will have to examine the secondary or unintended consequence effects of the sounds on people, cats, dogs, and other animals. And we want to make sure that we can do proper comparisons with competitor technologies now that we actually have something working and we have a better intuitive feel for what is required in the components and subcomponents of our system. We now move on to the next stage where we have to start testing and further refinement of our prototype and system integration. And so this is outlined in the Gantt chart on the right. It will be affected in part based on the fact that we have accreditation reports and visits occurring in January, and we have December-based final exams to grade and to submit grades for. So as we develop our system, we will be working on the mobile version, the caging system, the transportation module, and disposal systems. We will be working towards the integration and testing, as can be seen in the Gantt chart right there, all in the lead up to the open house at the end of the second semester. As with all good reports, it's important to do a self-assessment, and we have conducted a self-assessment using the rubrics from the governing document. You have access to those as well, and all students should be using those rubrics to evaluate their own reports and to describe the self-evaluation process they went through.